For this review video for our Unit 4 test, I'll take you through one of each type of problem, essentially. So I have highlighted what problems I'll go through. So starting with number 3, radical equations. The idea is you want to isolate the radical by doing inverse operations, and then you're able to square both sides to solve. So for example, I would first subtract the 3, then divide everything by 2. In order to undo the square root, I square both sides. So that leaves me with x minus 3 is equal to 1. So that means x is equal to 4. Then you can check your equation by going back to the original, plugging 4 back in for x, and seeing does it check. Does the left-hand side equal the right-hand side? 4 minus 3 is 1. 2 times 1 is 2. 2 plus 3 is 5, and that does check. So x equals 4 is our solution. On the test, you'll have to simplify radicals, both square root and cube root. Starting with number 6, I'm going to simplify the square root of 48x to the 16th, y to the 13th. You'll have to know your perfect squares, and if you ever struggle coming up with factors of a number like 48, you can use your calculator by going into y equals, putting in 48 divided by x, and looking at your table of values. So looking at the table, I can see that 3 and 16 are factors, and 16 is the biggest perfect square I can get. So I will break this up into good radical, bad radical. So 16, 3. Any exponent with an even number will go in the good radical. And for odds, I'll have to break that up into biggest even and our leftover odds. So y to the 12th and y to the 1st. I'll take the square root of everything in the good radical, so that's 4x to the 8th, y to the 6th, times our leftover square root of 3y. In order to take the square root of variables, I'm just dividing each of these by the index, which is 2. When it comes to adding or subtracting radicals, you guys need to make sure you have the same radicand in order to combine. So for example, 2 radical 2 plus 3 radical 2, same radicand, means you can add the coefficients, and that leaves you with 5 radical 2. So for number 11, I can't combine them as is because 200 a to the 7th is not the same thing as 50 a to the 7th. So I got to break them down to see if I can get a common radicand. Biggest perfect square in 200 is 100. And then I'll put the a to the 6th in the first radical, which means I have a leftover 2a. Minus, biggest perfect square in 50 is 25. Then I'll do the same thing with a leftover 2a. 25 times 2 gives me 25. A to the 6th times a gives me a to the 7th. Then I'll take the square root. So 10a cubed, square root of 2a, minus 5a to the 3rd, square root of 2a. I have the same radicand, so I can combine the coefficients, and those are like terms as well. So 10 minus 5 is 5, so 5a cubed, square root of 2a. Okay, as far as multiplying goes, make sure you multiply first, then simplify. So for example, starting with 14, 3 times 6 is 18. X to the 3rd times x is x to the 4th. Y times y squared is y cubed. I'm just adding my exponents there. Biggest perfect square in 18 is 9. And then I'll put the x to the 4th y squared in the good radical, which means I have a leftover 2y. Take the square root of everything in the good radical, and that's simplified. For number 16, make sure anytime you see a binomial, so that's two terms combined with either an addition or a subtraction sign. When I have this being squared, I write this out twice, and then I FOIL. So first gives me 36. Minus 6 radical 5. Minus 6 radical 5. Then negative times a negative is a positive. 5 times 5 is 25, but that's under the radical. Okay, so these do not go to 0. Be careful there. Those are the same thing. So this is 36 minus 12 radical 5. Square root of 25 is 5. 36 plus 5 gives me 41. So 41 minus 12 square root of 5 would be my answer there. Now, as far as 15 goes, that one's dividing. Divide when you can. So 15 divided by 5 with the coefficients is 3. Under the radical, 27 divided by 3 is 9. Square root of 9 is 3, so this whole thing actually just goes to 9. 18, I give you another multiplication problem. Keep in mind this one's actually a cube root problem. So I'll keep the cube root. 9 times 6 is 54. X squared times x to the 5th is x to the 7th. And now I'm actually looking to break this up by cubes. So make sure you know your cubes, your perfect cubes. So that's 2 cubed, well 1 cubed, which is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. So when I look to break this up, the good radical is going to be 27, because 27 times 2 gives me 54, and that's the biggest perfect cube. As far as variables go, I'm looking to break it up so that the exponent is divisible by 3. So I would put x to the 6th in the good radical, because I can do 6 divided by 3, which means I have a leftover x in my bad radical. Cube root of 27 is 3. And then I'm dividing 6 by 3, which gives me x squared, times the cube root of 2x. Make sure you don't forget that little cube root symbol. Okay, and then square roots, and I'm dividing. This is where you're going to divide each part by the bottom. So I'll actually rewrite this out separately. So radical 32x to the 5th over the square root of 2x plus radical 48x cubed divided by 2x. Okay, now you can divide under the radicals. 32 divided by 2 is 16. X to the 5th divided by x is x to the 4th. Plus 48 divided by 2 is 24. X to the 3rd divided by x is x squared. Now each of these I can break down. 16x to the 4th is 4x squared. Plus, now biggest perfect square in 24 is 4. X squared will go in the good radical, and then I have a leftover radical 6, because 6 times 4 is 24. So this is 4x squared plus 2x square root of 6, and that's as combined as it's going to get, because these do not have common radicands. You cannot combine them further. Last thing on this test is going to be rationalizing denominators. Rationalize means that you no longer have a radical in the denominator. So for example, in 20, I'm noticing that I have a square root of 2. What I'm going to do is multiply top and bottom by the square root of 2. So that gives me 10 square root of 2 divided by 9 square root of 4. Now the reason we do this is because now the square root of 4 is 2, and 9 times 2 is 18. So in doing so, I got rid of the square root in the denominator. Now it says write our answer in simplest radical form, so that means I have to simplify any coefficients. I've noticed that each of these is divisible by 2. So my final answer is 5 square root of 2 divided by 9. And if you're ever unsure about the simplifying, you could go in your calculator, and do 10 divided by 18, and hit Math Frac, and it will reduce it for you. Now, that's if I have a monomial denominator. Monomial meaning one term grouped by multiplication, because it's 9 times radical 2. In 22, I have what's called a binomial denominator because I have 2 terms grouped by, in this case, an addition sign. So that's where I'm going to multiply by what we call the conjugate. I multiply by 1 minus the square root of 2 in both the top and the bottom. And we will distribute out. Now, I actually do this off to the side. No, I'll do it right below it. Okay, so I multiply these out, and I FOIL. 1 times 1 is 1. Then I get minus radical 2 plus radical 2 minus radical 4. Now, because this is a positive radical 2 and a negative radical 2, those do cancel out. Those go to 0. And this leaves me with 1 minus 2. 1 minus 2 is negative 1. So that's our denominator. That will always happen. You will always have those middle, inner, and outer terms cancel out. That's the purpose of the conjugate. In the numerator, these are not conjugates because they have the same signs, not opposites. So you have to completely FOIL out here. So 1 times 1 is 1. Then I get a minus radical 2. Minus radical 2 plus radical 4. Now, these are not opposites with opposites with a negative sign. Those are exactly the same. So keep in mind this is 2. So 1 plus 2 is 3. And then you have 2 negative radical 2's. So minus 2 radical 2. All over negative 1. And then I actually can divide these further. All I did was divide each of these by negative 1. 3 divided by negative 1 is negative 3. Negative 2 divided by negative 1 is positive 2. And that's how that came about. And that would be our final answer.